Hello friends, welcome to this third video on power spectral density. We have been doing problems under power spectral density. This video will help you solve a problem when the input function is going to be exponential in nature. The problem goes like the autocorrelation function of a random telegraph signal process is given by r of tau equal to a square e power minus 2 times lambda modulus of tau. We will have to determine the power spectral density of the signal. So what has been given to us? We have been given an autocorrelation function and we have been asked to find out what is going to be the power spectral density. Given r of tau, we have to find what is going to be our s of omega. And how are these things related? We know that power spectral density is nothing but the Fourier of the autocorrelation function. So we will try to recollect the formula which we used for it. What do we know from the formula? We know that Sx of omega is Fourier of Rx of tau. Fourier is going to be a function which integrates the value from minus infinity to infinity. The input function is Rx of tau with an exponential part which is going to be negative in nature. You will have to keep in mind that exponential is negative for a Fourier value. Now how our function has been defined? What is going to be my input function? Now this will be equal to integral from minus infinity to infinity. My input function Rx of tau has been given to me as a square e power minus 2 lambda. 2 is a constant, lambda is a constant. Tau alone is going to be my autocorrelation function's variable. You have your e to the power of minus I omega tau, and now you have your d tau. This a square being a constant will not be affected by the integration. Let us take this a square outside. So a square comes outside. Integral from minus infinity to infinity e power minus 2 lambda times modulus of tau e power minus I omega tau d tau. Now few things which we saw as hints will help us to solve this problem in a better way. Hint number 1. When the input function is going to be exponential, keep this exponential function as such. Do not split it as cosine sign. You split it as cosine sign. When it is going to be algebraic, then it will become easy for you. But now since your input function is exponential, keep this as exponential, because we know that e to the power of a product e to the power of b can be written as e to the power of a plus b. So I am making use of this property, and what we have is e to the power of minus 2 lambda times modulus of tau e to the power of minus I omega tau. So I am going to club both of them as e power minus 2 lambda modulus of tau minus I omega tau. So what I am doing, I am clubbing these two quantities as one single entity, and so integration will become easy for me. So this is my hint number 1. Hint number 2. So this is going to be my hint number 1. Hint number 2. What do you have in your hint number 2 is, whenever we find modulus in my input value, we have a modulus over here, then my integral from minus infinity to infinity has to be split and write as minus infinity to 0 as the first part and 0 to infinity as the second part. This is because modulus behaves entirely different in this region from minus infinity to infinity. It takes a negative value between minus infinity to 0, and it takes a positive value between 0 to infinity. So in this zone you have the value to be negative, in this zone you have it to be positive. So the next point is you will have to split and write. So what happens over here is, I write my Sxx of omega from my previous slide as a square is a constant. So let me take it outside, and this integral which is going to be from minus infinity to infinity, what I am doing, I am splitting it as minus infinity to 0 and the second integral from 0 to infinity. A square is constant to both the quantities. So this is my second step. Now what we know is, in minus infinity to 0, what happens, this modulus takes a negative value. So you have it as e power minus 2 lambda into, what will happen to the modulus? modulus will take a negative value. Okay, and minus I omega tau. So this is going to be my third point which I need to keep in mind. And what will happen to the zone from 0 to infinity? 0 to infinity, modulus takes a positive value. So what will happen to this modulus? It will become e power minus 2 lambda times, this will become positive tau minus I omega tau. Now the integration has to be carried out with respect to which variable? With respect to d tau. Keep it in mind. So d tau, so you put here as d tau. So we have one function exponential which has to be integrated with respect to d tau. Now coming to my hint number 4. What was our hint number 4 was, whenever we have one of the quantities to be minus infinity, what we need to do is we need to keep this exponential to be positive, so that when I apply the variable will take the value of minus infinity and this will move towards your 0. So when I have minus infinity, I need to keep my exponential positive, so it becomes tau times of minus into minus will become plus. So 2 lambda, this is going to be minus, so minus I omega times. So what do I do is, whenever I have minus infinity to your value as minus infinity as one of your limit, keep your exponential as positive. So what I am doing over here, I am keeping my exponential as positive. Now in the second zone, what happens in the second zone? You have the limit as infinity. When you have infinity, then what you will have to do? You will have to keep your exponential as negative. So what you will have to do is, you will have to pull minus tau outside. What you will have to do? You will have to pull minus tau outside. When minus tau is pulled outside, what you will be left out is 2 lambda. Since minus has already come outside, this will become I omega. So in the second zone, from your 0 to infinity, what happens? Your value for your exponential keeps as negative. In minus infinity to 0 zone, keep your value as positive. So now when you apply tau as minus infinity, this will move towards your 0, and when you apply tau to be infinity, it becomes minus of infinity and it will move towards 0. So this is going to be the primary idea behind it. So we move on to the next slide. So my Sxx of omega is equal to a square integral from minus infinity to 0 e to the power of, I have it as tau into 2 times of lambda minus I omega into d tau. And in the second zone, from 0 to infinity, I have minus lambda times of, minus tau times 2 lambda plus I omega into d tau. Now we are ready for integration. We need to keep in mind e power a theta on integration with respect to theta gives us e power a theta divided by a. So the constant has to be divided. So which is the constant over here for me? With respect to lambda, lambda is my variable. So which behaves as a constant? The constant is going to be 2 lambda minus I tau. Now with respect to our value for lambda, lambda is the variable, so minus lambda will be the variable part, and which will be the constant part? The constant part over here in the second term will be 2 lambda plus I tau. So keeping this in mind, what will happen now? When I integrate, I will have e power tau times 2 lambda minus I omega divided by 2 lambda minus I omega. So this will be my integration, which will be valid between the limits 0 and minus infinity. And the second limit, e power minus tau times 2 lambda plus I omega, which is the constant here, 2 lambda plus I omega, but there is a negative sign, so minus sign of, and this has to be applied between the limits 0 to infinity, and a square is common to both these terms. Now let me apply the limit. What happens over here? Lambda takes the value 0, lambda takes the value minus infinity, and we need to keep in mind what is going to be our e power 0 is going to be 1, and e power minus infinity will be equal to 0. Keeping these 2 points in mind, what happens over here, e power upper limit is 0. What is going to be e power 0? 1. So you have 2 lambda minus I omega. Upper limit minus lower limit. What will happen to e power minus infinity? E power minus infinity becomes 0. Now moving on to the second term. What happens over here, you will have lambda take the value, upper limit is infinity, lambda takes the lower value, lower limit is going to be 0. So what will happen, e power lambda takes infinity, so it now becomes minus infinity since it is minus infinite. What is e power minus infinity? So the first term becomes 0, second minus sign of e power minus 0. What is e power 0? E power 0 becomes 1 divided by minus 2 lambda plus I omega. So this is going to be my limits after substitution. Now I have to simplify this process. So moving on to the next slide, I have this as a square into 1 divided by 2 lambda minus I omega, 2 lambda minus I omega, and this minus of minus will become plus. So plus 1 divided by 2 lambda plus I omega. Now let me take the LCM. What will be the LCM? 2 lambda minus I omega into 2 lambda plus I omega will be my LCM. Now this will be multiplied with the missing factor, which is 2 lambda plus I omega, plus sign. This will be multiplied with the missing factor, which is 2 lambda minus I omega. So now this I omega can be cancelled off. You will have a square, 2 lambda and 2 lambda will make it as 2 plus 2. So it is 4 lambda, and in the denominator this is of the format a minus b into a plus b. You can use it as a square minus b square. So you will have 2 lambda the whole square minus b. What is in place of b? I omega the whole square. What is I square? We need to keep in mind I square is equal to minus 1. So you will have 4 lambda a square divided by 2 square makes it as 4 lambda square, I square makes it as minus of minus plus omega square. So the final answer for this problem will be 2 lambda a square into 4 lambda square plus omega square. Thank you.